Okay, welcome to another class and another week. Right, this week we will be talking about fire sprinkler systems. Right, it's very similar to plumbing systems, but it just has some extra details, very important details. Right, so and it's mostly or it's to be able to effectively fight against fire. Right. So a fire sprinkler system is a network of pipes and sprinkler heads, right, that discharge water to control or suppress a fire, to and that in turn protects life and property, and then it also support firefighter operations, and it's usually automatic, right? So each sprinkler operates individually when exposed to sufficient heat. So the way it works is that if one of the sprinkler um, senses heat, it turns on, right? So it doesn't like turn on every sprinkler in the network, just that one. Only if maybe the fire spreads or the source of heat spreads, then it turn on more that are in that proximity, right? So moving on, sprinkler, what are the different system types, right? According to this NFPA, right? NFPA stands for National Fire Protection Association, right? So the different types include there are four major types, right? So the first is wet pipe systems, and it basically just means when the pipe is always filled with water and is the most common and reliable, and is used in heated spaces, right? But there are cases where it can get frozen, or cases where you don't want water. Maybe you need something that takes a bit of time to delay before it responds, right? So that's where other types of systems come into play. This one is filled with air because freezing is possible, and if the water freezes in the pipe, it's useless in that period of time. Then this one's pre-action because it requires detection, because this one is mostly used where you don't want, I mean, most times the wet pipe response system is very fast, or it's just fast, right? And sometimes it can be a false alarm, right? So this one now, this pre-action system, it needs like a bit of, it needs like some solid detection before it releases. And if you see, it's used in sensitive areas, right? Where if the water just goes off due to a false alarm, it can cause damage, right? So I mean, if the water is going off, let's say that there is actual fire, right? And then we have deluge system that is usually for high hazard areas, right? So, but the one we'll be talking about most and designing in this class is the wet pipe systems, right? So now let's talk about hazard classifications. Hazard basically refers to the types of the possibility of fire outbreak and the amount of fuel. You know that for fire to take place, there needs to be oxygen, source of fuel, and heat, right? So any space or building or occupancy that has these things, either one of them or all of them in a large quantity, is referred to as a high hazard zone, right? And also possibilities of ignition too, right? Those are high hazard zone. So they are classified into three. These are the three basic ones. There are more, right? But these are the ones we'll talk about, right? So light hazard is just basically like offices, classrooms, very basic, right? The least possible, maybe homes, right? And why you need to classify them is so that because they have the varying um, details when it comes to designing their systems, right? So the max area for this one is 225 square feet or 15 by 15 feet, right? This just basically means this is like they are saying it as though it's a square, but I like to look at it as a circle, right? Although it can be either, but I like to look at it as a circle because when a sprinkler goes off, it goes in like a radius. It goes in like a radius, like a circle, right? And then for this one, the water density is the lowest because you don't need so much water. Water density just we'll talk about it. Just basically referring to the amount of water per area, right? How dense it is. So we go on to the next category or classification, which is the ordinary hazard. There's level hazard level 1 and 2 under this, but this one basically just refers to retail stores or any place that has to do with retail. Is now we are still talking about like commercial um, um, buildings, right? Parking, there's a lot of cars, right? And then workshops too, possible ignition, right? Now, if you notice this one, it drops, so almost about half of this. So in this case now, one sprinkler is expected to cover a smaller area. So that means over like a full building, there's now like more sprinklers per area, right? Because they expected that the fire breaks out here, it has a higher possibility and it has a higher um, chances of damage, right? So it's now smaller, right? And that also goes with the typical spacing for each of the um, sprinklers. So it's now smaller. So it now becomes a radius of just 12, right? A diameter of 12 rather, because I mean, think about it. If you take a circle or if you take a square that's 12 by 12, if you now want to put a circle that fits into that perfectly into that, I should have drawn this, right? Do we have time to do that? I mean, I just want to illustrate as much as possible. Let's see whether we can do that. Right. So this is what I mean. So I mean, is it 12 by 12, right? This is 12. This is 12. Now, if it is a square, but a circle now covers a slightly smaller area, and for this circle to be able to cover that area, it's going to have a diameter of that same 12. So it means the radius of the circle will be half, which is 6, right? So moving on, we now have a higher level, which is extra hazard, right? Don't forget that this ordinary hazard has two levels, right? Extra hazard also has 2 levels. So I mean, by the time you go through the NFPA, be able to and you do like extra research, you see all those different levels and you see that some little extra differences, right? So this one is even smaller and has closer spacing. And okay, I also forgot to mention, you notice that as you go increase in the level of the hazard, you see that the density increases too. So now this one requires more water per fill. Look at it here. The water density is amount of water applied per unit area, right? As you can see, GPM. GPM is something that you're familiar with, a unit you're familiar with. The volumetric flow, and then per area, right? So as it increases to this point or up to 0.4. Probably can even be more than this, right? So that it's like deploying as much resources as possible to turn off the fire, right? You can even see that it's up to 4 times the original, right? And then it can't be less than this, right? So moving on, zoning system. So I mean, we talk about zone a lot. We talk about zones a lot. Like talk about zones in mechanical system, talk about it in plumbing systems. Well, zones just basically means dividing your system into logical sections based on different criteria, right? It helps identify the fire location so that the person is not confused. To pinpoint it basically, then it limits system impairment during maintenance, right? It just basically helps to streamline things because instead of just one large thing, now there's like fewer places to like look at, right? And then it improves the reliability and is required especially in larger buildings, right? So I mean, the larger a building is, the larger the chances of you should zone it, right? For example, some methods you can zone by the floor. By the time you have multiple floors, that is a very good reason to put them into different zones. There's each floor is going to be a zone of its own. So like as the pinpointing takes place here, if there's a fire on one floor, it's easier to pinpoint it on that floor, right? Because the sprinkler system would have activated for only that place, right? Then also by floor area. So as you saw here too, all this has to do with floor area, right? And not just floor area, but the nature of that space of that building, right? And how it varies and how that influences the environment within that space, right? And all of these just basically contributes to like different hazard types. So hazard type is another reason why you should zone. right? For example, now in a building you have a chemical lab. In that same building you have a gymnasium. In that same building you have a theater, like a theater or a cinema, right? You realize that these are different types of zones, right? One of them has a lot of people crowded in a place. One has chemical um material that can cause fire or that can burn rapidly. Do you get? So things like this, right? Then also by the occupancy type, which I just mentioned, right? So I mean, this has to do with either residential, commercial, and the purpose of that space. There are other things, right? On your discretion as an engineer, you can decide that okay, this place now maybe is too big, or these are two different sorts of things. I'm going to zone it accordingly, right? So each zone typically has its own control switch, and then when it has to be tested, it's tested differently too, and pressure gauge. That now this is another importance of zoning, right? I mean, don't zone when you don't have to. It's not as if you should always zone. You zone when it's like when it's necessary. So one importance or one advantage is that it helps to pinpoint, right? You can test the system individually, and if there's anyone that is faulty, you can just adjust or make changes in that system or repair in that smaller section, rather than when it's one large system and you can't really trace, right? So next we'll talk about sprinkler spacing and coverage rules. We've already spoken about this a little, right? So let's just dwell on some specific important information, right? So spacing is usually perpendicular to branch lines, right? This just basically means that if you have the lines, I will use a diagram to show you this, right? Okay, let's use this, right? This is the lines. Perpendicular is measured like this. So you measure this from this to this point, right? So that's how it's measured. So I mean, at the end of the day, if you are using the correct radius of this square footage or this 15 feet or 12, whenever the case called you need arises, if you're using that, you always find out that whether on perpendicularly or parallel in all directions, you find out that there is a sprinkler within that 15 feet of this particular sprinkler, right? So it's important to note that, because if you don't, you're just going to provide a failed system for you, right? Next, talk about the maximum spacing, right? So this depends on the hazard class, as we mentioned. Now next is the maximum area too, which depends on this thing, right? On the hazard class too, right? And it must not be exceeded, because if it's exceeded, there's going to be blind spots or areas that the sprinklers don't get to, right? And you understand how that can be a safety hazard. Next, talk about the distance from the wall. So now when you're in the middle of a space, right, you have the radius stretching out in all directions, but by the time you get close to a wall, it's no longer in all directions. Now you have a wall that is an obstruction, right, or it's like the end of that place. So this is basically saying that the distance from the wall it should be about half the normal spacing, right? So if it's 15 feet by 15 feet, it means the distance from the wall should be less or equal to half of that 15 feet, which is 7.5, right? Which is still that radius we spoke about, right? So that you will not say because it's close to a wall, it gets too close or too far from the wall. So you just take note of that. Then the minimum distance too. You see, it's all about distance. Distance is always 6 feet, right? 6 feet, right? So this one mostly applies. You've seen that this radius is where we divide our 12 into 2, right? So moving on, sprinkler performance, right, is also affected by geometry. So it's not just by the spacing and then the coverage area, it's also geometry, in the sense that if it's installed on like maybe ceilings, now it's mostly installed on ceilings. It could be there are also wall sprinklers that are installed on a vertical wall, right? So these things also come with their different priorities and different expectations, right? So design criteria rather. So now special attention is paid, for example, when you are dealing with sloping ceilings, right? To check the code and get that information. So avoid obstructions. So I mean, when you are designing, you're going to encounter a lot of possible obstruction, because a house or a building is one that requires a lot of different systems for it to like work together, right? So as you are designing, you come across beams which are structural elements, ducts which are mechanical elements, lights which are electrical elements, and so on and so forth, right? So it's important that you align, you get all the information from like all the different people you are working with, right, as much as you can get, and ensure that. And then also there will probably most likely be drawings that they've sent in already for you to check and ensure that there's no clashing, right? Very important, because if for any reason a sprinkler is obstructed by one of these things, right, it's going to reduce its performance. Okay, and then you, when if the need arises, you're going to add additional sprinklers to make up for that um, obstruction, right? So now let's talk about hydraulic design. So this just basically refers to how the sprinkler system are designed so that the most hydraulically remote sprinkler receives the correct flow and pressure, the required minimum, right? So I mean, just like how like we spoke about pressure drop in pipes or in ducts, right? I mean, the farther the water travels, the the more the ability to put out fire drops, the pressure, the flow, everything drops to like almost static, right? So that's why this is important, right? And this most hydraulically remote is the one that is affected the most, the one that's affected most by that pressure drop, right, and that distance. And you see that it's not just those two, there are a lot of factors that play a role in affecting its performance, right, which is in terms of the length, the size, very important, the fittings cause pressure loss, right, because of changing direction and changing section area. Then elevation too, when it has to go vertically upward, it loses pressure, right, and velocity too, right, because so you need to like make up for it, right. Then friction losses too, I mean, depending on the pipe material you've chosen, right. I mean, if you're able to get any pipe that is smoothest, the smoothest pipe possible is usually the best, right? Although in some cases it might not meet in terms of maybe structural strength, right? But it's something you need to put into consideration when that is why this hydraulic design is important, right? So these calculations verify that the water supply can meet the system demand, the total system demand, right? So I spoke about the materials. So these are some commonly used pipe materials when designing sprinkler systems, right? So now moving on, how water density is used in design. So we spoke about water density, which is the amount of water per area, right? And we'll also talk about how you don't use one sprinkler at a time, right? So I mean, as we spoke about here, the most hydraulically remote sprinkler, right, you don't just use just one, right? Basically this whole calculation is to ensure that that building is completely protected, sufficiently protected, right? So you will not just use just the last. Besides, sometimes that last one you're selecting that you think is the most hydraulically, based on just looking at it, might not be, right? So that's why you need to like expand area. That's where the area comes into place. So it's not just one, you look at an area, right? So now you select the density based on the hazard level of that space. Then the design area usually is around 1.5 to and above to 2.5 square feet, square feet, right? Okay, square feet, right? And it increases. This is usually like for the lowest hazard level. It increases with hazard levels, right? So I mean, if the most remote or the farthest away, this hydraulically remote, right, if that the most remote 1,500 square feet area, right, is covered, if you design for that place to function properly, it means the rest of the sprinkler system will work, right? So then to get the total flow, this total flow is just the amount of GPM that we are sending into that space, right? so that you now multiply it and get it. So to an example is when we have a density, remember this is for hazard group 1, and then this is what the density is, and then this is the design area, which is kind of fixed for um lower hazard levels, right? But then the thing is that we may not always get buildings as large as 1.5, right? We may not always get buildings, they're always smaller buildings, right? So but at least the whole point of understanding this is just knowing that that section, right, is covered, right? So then you do your calculations and get that this is just like an average and example of what it looks like when you have like a very large building, because I mean the larger the building, the more these things matter, right? But in a case where the building is not that large, right, you can select what you think work based on your own discretion, right? So now there's also another thing we talk about, which is called, so this is the flow, right? The system demand, right, separate from host allowance. Now let's talk about, okay, we'll talk about host allowance shortly, but before we do that, let's talk about the pressure levels, right? So typical pressure levels is usually around 50 to 85 psi, right? If we check when we are getting like pipe sizing from regular plumbing systems, it's around these same values, right? I mean, it could be more if the building is extremely large, right? But these are like some typical values where it falls into. Then residual pressure is like additional pressure, right? Of this, I mean, there will be space for it to like fill this in. This PSI too, PSI, right? Then the flow, basic flow, is usually around 200 to 1250 GPM or more, but this is the basic, the like a very average range. So you see here we got 225 GPM for this, right? So I mean, you could use less, but to be on the safe side, use a minimum of 200 GPM, right? Then now let's talk about that host stream allowance we talked about earlier here, right? So this host stream allowance is like supplementing the existing, or you've selected a system or a flow. Okay, let's read it here. In addition to sprinkler demand, which you've selected as 225, host allowance, which is around 100 to 500, depending on the hazard, with 100 being the lowest and 500 being like higher, right, is added to ensure that the water is available for manual firefighting operations. Basically, it's meant to supplement the system, right? If for any reason, this is like over design, let's put it that way. So it's like is a section, right, of water that is added to the, you've already calculated though, but it's like a factor of safety, right? And also, if for any reason there's need to like use that same water supply to do extra firefighting, it's going to be available, so that it doesn't like, it's just like how you supply, you size your pipes, your plumbing pipes such a way that if all the fixtures are on, it's still able to meet the demand, right? So that's how it is, because you never know, right? So now let's talk about sprinkler layout. So there are two major types, which are tree system and grid systems. Now let's look at what they are before we talk about like some details, right? So now tree, as you see, is just a major branch that a major distribution pipe, and then you have branches off of it, right? This is the simplest way to lay out your sprinkler pipes. But now there's a bit of a problem, in the sense that as you travel down this pipe, pressure and flow drops, right? Flow with like volume drops, right? Flow and velocity tends to be confusing sometimes, right? But it's flow and pressure, right? So, and when you say pressure, I'll talk about static pressure, right? Okay, so you see now that at the beginning of this pipe, the flow and pressure is the highest, but as you go towards the end, it drops. So that means that the sprinklers at this point, the farthest away from here, are going to receive the least action. And this also means that these are the hydraulically remote too, right? So I mean, usually this is what your hydraulically remote looks like, right? Now, for simpler, smaller buildings, this works because maybe you just go here, maybe just stop somewhere here, maybe just two sprinklers to the left, two to the right. I mean, the difference is not much. But by the time you are talking about bigger spaces or bigger buildings, we switch over to using either the loop or the grid method. And one thing that really stands out in these two methods is that instead of one major pipe, we have two. So when the main supply comes in, it splits into two first, right? So that as it gets into the sprinklers, you are getting like supplementing water from both sides. So now instead of now you just have to concentrate on adding as enough flow and pressure which is going to be distributed properly, as opposed to this one where if you add it here, majority will be around here and then this one suffer. But with this now, before it gets to why this one is as they're working, there's still like relatively enough pressure to go into all these ones. And if it drops, this one also makes up for it, right? I remember that they don't all function at the same time. So at every point in time, there's like water, like enough pressure around, similar to grid 2. So it goes round and goes round into two pipes, right? So now this one now is one part, one major part, right? And this one is mini parts, right? Now this one can be engineering challenging, right, in terms of calculations, in terms of the layout, right, but it is usually more efficient. Now this one involves long travel. Now because this one is it has so many ways to get to that pipe, it's usually shorter travel, right? Then this one has higher loss, that pressure loss you spoke about, right? Because I mean it's just one main pipe, so the pressure drop and flow drop is going to be high, while for this it is lower. Then this is cheaper to do. I mean it's very simple to design, but this not only does it require more pipe, but it also requires more technical know-how, right? So most times you're going to be revolving either building either this or this, right? Moving on, and this applies most time, like I said, in larger building spaces, right? So let's talk about K factor. Now we've talked about the pipes, talk about the arrangement, talk about the spacing. Now let's talk about the sprinkler itself, right? So the sprinkler in this case, this sprinkler has a K factor, right? This K factor relates to the pressure and flow, right? And larger K factors basically means delivering more water, right? More water. So you are seeing here that these are the different common values, right? And you see that when it's smaller, it's less water but higher pressure. Now when it's larger, it's more water but lower pressure. Now it just basically means that this one has larger openings. When this K factor is not just a function of just the size, right? It's a function of both flow and pressure, right? So I mean at the end of the day, that is like a constant based on that particular sprinkler, right? And I see that some common values selected are 5.6, 8.0 to this for larger values, for larger sprinklers or larger openings. And then you have even this one, which means early suppression fire something, right? This one is rare, but basically why this you have changing values is because if for any reason there are a lot of factors that can not, when you do your hydraulic calculation, there are a lot of factors that can make your system not to perform properly, right? So it could be the arrangement, but by the time you set all those things right and things are still not working, you start to adjust the standard, you start to adjust the key factor values, and that's just going to permit more water to like go into that space, right? So now let's talk about some codes, right? So applicable codes, the one we've referenced a lot is this NFPA 13, right? And it basically talks about how the sprinklers should be installed, the rules, and then the details and all of that, the primary code that should follow, right? And if you see, it applies to commercial and industrial. It also applies to residential, right? Unless excluded, which is a special case, right? It also applies to new construction and major alterations, right? Now, this just basically means that if you're installing in a building that's older, this may allow you some little lapses, right? Now, it covers all these things that we've already spoken of, right? Now, let's talk about the next one or another one, which is referred to as 13R, right? 13R. This one focuses on low-rise residential, right? So now this low-rise residential basically refers to buildings up to residential buildings up to 4 stories, right? And you see examples of apartments, hotels, dormitories, right? So there are some buildings that fall into both these categories, right? So you just select the most efficient way. I mean, there's not much difference in designing. There is not as if they are so far apart. It's just that this is the primary code to use when your building falls into this category, right? Then there's also this one, like for 1 or 2 single family homes, right? Now, this is another code that we usually refer to, right? So we have international plumbing code, we have international mechanical code, right? This is building code. Building code is like the mother code of a lot of codes, right? It just basically, like name implies, building. It basically builds, ensures that a building meets all possible requirements, right? It may not give you in details, so it's not refer you to one of the other codes, but it basically talks about, it is talking, telling you when you need the fire protection system, and then it also gives us an idea of different occupancy types, right? So IBC basically tells you this building needs sprinklers, while NFPA 13 tells you how to design them, right? So it gives you more details. So now all this part just refers to the extra information. I'm not going to dwell on this part so much, right? So you just need to do your personal research on it. All this is just referring to extra information on sprinkler design, right? So how the details, you may not always put these things on your design, right? That's why I'm not going to dwell on them, but you will need to include them in notes, right? To ensure that these designs are followed, and then they follow the code too, right? So you see the components that you need to add, and then you see why you need to add them, right? Next, talk about water supply reliability. Now, just like in regular plumbing system, water supply systems, right? Most of them get it from the municipal water supply, which is the city's network of water supply, right? Now, in regular plumbing systems, the pressure and flow, the impact just maybe convenience and comfort, right? But in fire systems, this can influence whether that system performs well or not, and that has a higher risk factor, right? So if you're that's why you also need to do your hydraulic calculations, and if and when you do it and it doesn't meet criteria, you may need to recommend or install fire pumps, right? Another reason why you may need to install fire pumps is if maybe they are supplying from a well, or maybe not that general system, because this municipal supply has its own pressure levels too, right? So I mean, if for any reason that pressure or the pressure of the supply water doesn't meet your criteria, right? You know, remember we talk about residual pressure and static pressure in like somewhere up. So those are the, by the time you fill in all these things, right? And then for any reason the system is not performing like you put in your calculation, and you see that it's not performing rightly, right? You now need to increase that pressure, and increase that pressure basically just means adding pumps, right? Or tanks to supplement the water supply. Now, this also is inspection, testing, and maintenance, right? Just like these parts where you have to add notes for them, this is also about notes. Even this water supply reliability, if for any reason you discover that it is not, you add these notes. Why do you add this note? So that whoever is building on site, the contractor, the building engineer on site, is able to make, by their own discretion and by the information you provide them, make informed guesses or informed decisions on what to do and why, right? So things like how often the place should be tested, and how often it should be maintained, and some details basically, right? Inspection and all of that. So now this is what our checklists look like. So for designing a proper fire sprinkler system, so let's get into that real quick. Before, let's design the system for a building, right? Okay, so this is a building that we've designed on. It's a small building, so that we don't spend too much time, right? And then let's design fire sprinklers for this building, right? So what's our first step? First step is to determine the hazard. So this is a retail space, right? So that tells us that it is ordinary hazard 1, right? I mean, it's a small space, ordinary hazard 1. So that also means that what else? Oh, what else? It has a spacing of 12 by 12 and then water density of 0.5, 0.15, right? Meaning that it is the hazard level 1, not 2, right? Right. Okay. Let's do that real quick. Okay. So we've done that. Now we're selecting the appropriate sprinkler system type, which is the wet pipe sprinkler. So that's what we are designing for. So now ensure proper spacing and operation control. Right, so we're going to use 12 by 12, right, which is a circle, a coverage area of 12 diameters, which is 6 in radius. Right, so I'm just going to draw something here. This is going to indicate my sprinkler. Right, now I want it to cover an area of 6 by 6. Right, I've already created a layer for that. Oh shit. Okay, which is this. Right, so this basically just, let me go over to this layer, make it this thing. Right, so how I got here was that I just simply drew a circle around, not even done that, around this, and give it, this is where I specify my diameter. So my diameter will be 12, right, 12 feet. Enter. Right, this is how we got this circle. Right, so now we're going to take this and we're going to arrange, scatter it across this building. Okay, not scatter, but arrange it across this building with this on. I'll also explain to you why I had, right, why I had to put it in a different layer. So okay, this, use this that is moving, can move around. So this is, you see the coverage area. So at least, oh, I should have copied it, not moved it. So copy, hold the center, and then put it one here, right? And also aesthetics is also important, right? So I'm going to put it in a straight line so that we don't just have it scattered anyhow, right? Oh, let's do a straight line. Okay, straight line. Why I can have these lines I can trace across this green line is because of these snaps on these two things. They help to, those two buttons help to maintain this straight line, right? Okay, I don't want to move it too far away, right? So now we still have some blind spots, but I mean we can't help it in this case, right? Then we have two more here. Okay, I'll be able to help it very soon. I've seen a bit of something I can change, a bit of change I can make. So this one will be somewhere here, and this one will be somewhere here. Right, so now if you see in this space now there is, I have no blind spot in this area. Okay, just this small space, right? So now because of these two that are here, I can just move this one up and cover up a bit of this space. So I mean you can't avoid blind spots, but you can try to avoid as much as possible. So if I move this up, I'll be able to make use of this space and a bit of space from here, right? Move up a little. So by doing that now, you see that I've used up that space and I've closed up these small spaces, right? Then I can even move this one up a little too. Okay. Okay, move this up a little. Now remember that this, okay, but you can just select, find out balance, right? Okay, so this way we have smaller spaces here now. So now why I put this in a different layer so that I can turn off that layer, right? I can move to this layer and then I'll turn off that layer, just make it not be visible, right? So now to reduce clutter. Right, so now with that, now I'm sure that each of these sprinklers covers that radius it's supposed to cover. Okay, let me turn it back on and explain something before I do that. So now remember that we have a 12 by 12 distance maximum, right? So being that this radius is 6, and the entire diameter is 12. That already means that by the time you measure from here to here is 6, and here to here, before you is already so close, so there's no way this is going to exceed that 12, right? Same thing for here, right? So you just have that range, right? Now let's turn it off and move on, right? Okay, so what are we doing next? Let's see, right? Applying correct density and design. Okay, that will be later, right? So now this is our what our design looks like, right? So we lay out our pipes, right? So we're already in the sprinkler pipe. If you notice, I like to have a lot of layers. It's better to have more than enough than necessary, right? And then for things like this, right, being that the water supply is going to come in from one of the sides in the building, I like to select a part that is not at the front of the building, especially in a commercial space, right? So I'm going to select something here, somewhere here, because this is like where people are likely going to be interacting, customers, right? So I'm going to select one that comes from here. So I'll simply draw my line. Now let's talk about that branch, that grid and tree system, right? Now this is a little design um, um, characteristic, right, that helps you design better, right? I mean, I could have taken my line and drawn it somewhere. Okay, turn this back on. That's easier to trace, right? Over it and then drag it and drawn it across like this. But by the time I do that, what am I doing? I'm giving this first, and then I'll draw it straight up. Maybe another line that goes here. Draw it straight up, probably something like this, right? And then join here. But I don't want to do it this way, because by doing this, I'm giving this first sprinkler too much pressure at the same time. So I like to, and also I'm giving this one too little pressure, right? Now it may not be very obvious because it's just two, but by the time you do this for a long array, you see that the effect is noticed. So what am I going to do instead? I'm going to try to do it in such a way that it is shared. So I come in around the middle instead of at one point, right? Okay, interesting. Right. So this way, as the thing comes in here, it splits into the two almost equally, and then continues its journey. Gets here and then continues its journey, right? So at the end of the day, this is what our design looks like. Now to size it, we have this pipe schedule, right, to enable us. This is a picture I'm going to share with you, right? You have this, and you see that this is what the pipe sizing looks like. So now this for the different hazards, and you see that it was done by NFPA 13, right? Although it's an old year, but this is like still very functional, right? And you see that in increasing hazard level, you see that the number of pipes, the number of sprinklers, right, affects the size of the pipe. So for this light hazard now, for 2 sprinklers, you need a 1-inch pipe. For 3, by the time you get up to 3, basically the supply pipe. By the time you have 3 sprinklers, like a pipe supplying up to 3 sprinklers, you need to increase it to 1/4. By the time it's getting to 5, increase it to 1/2. Getting to 10, increase to 2. This is just to ensure that the pipe meets the sizing, meets the demand, right? So in our own now, we are working with an ordinary hazard 1, which is this first column, right? And that means we have just 4 sprinklers. Where is that? Okay, how many sprinklers do we have? Right. Oh yes, we have 1, 2, 3, 4, 5. This now is needed. There's a area requirement, right, for sprinklers in a bathroom. I mean, it's quite not funny to put sprinklers in a bathroom, because what could possibly catch fire in a bathroom? But it gets to an area, there's an area limit, right, or a minimum area where you need to add sprinklers. So this one met it of about 55 square feet, right? That's why we have this here, right? So we have 5 sprinklers on plan. So that just basically means that we'll go with 5, which is 5 sprinklers. So it means our largest pipe is going to be one and a half rather. And then as it goes up, it reduces until it gets to 2. And that's what you see here too, right? So it's one and a half, and then as it goes, supply. This one is just 1 because it's one sprinkler supplying. Then this one, okay, this should be 1/4 because it's supplying 3. Okay, space 1/4. Okay, because it's supplying 3 pipes, right? 3 sprinklers rather. And then this one is just 1. This is supplying 2. So let's confirm 2 is what? 2 sprinklers is still 1 inch. Okay, that's okay. Then this is also 1. So the importance of this, it enables any person that's interpreting your design to be able to tell the size to use and to ensure that you are able to maintain the required flow and pressure, right? So now this is the layout. It's very nice to look at. So we're going to import this into our sprinkler software, because we also will need to like lay out the actual pipes, look at it at a 3D level, and then do our hydraulic calculations. So which software we are using? The auto spring software. So while we wait for it to open, we are going to copy out this because we have a lot of information on this page. I mean, we have just this, right? But we need just this on a page, so that is the only file we're going to import into that space, right? So that we don't have too much clutter, because right, if there are multiple elements on the page, it slows down the software, right? So I've created a for it, a card file for just this, right? So this is the file we're going to now. Sprinkler app has opened, right? These are available for some parts. No, not now, right? So let's start new drawing. Now something with this software is that it tends to close a lot, right? Taking a bit of time, so we need to be saving our work as we go, right? Okay, perfect. So right now it's empty. So then this is where we go and import file. Is it here? There's one here. Import, yes. This is not. Is it here? Import AutoCAD, yes. So we import that our file. I named it to AutoSpring because I want it. Oh, what does this mean? Oh, this is because I think it's because it's open. Let's see. Okay, it showed that because I see had it open right on this on card AutoCAD, and that just basically meant that I could make changes. The whole point of this is so that it will import that file, right? So I mean, it's happened very fast because it's a very and that is why I needed it to be alone on that page. So we have it here. So now I have a checklist to help me to design better in this software, because there's a lot of wahala that the software can give you, right? So one of those things, let's go to my checklist. Okay, so this is what we've already done some of these, right? So we lay out our sprinklers, use these radios for light hazard, right? I mean, then lay out and add sizes, which we've done that. Import into sprinklers, this is where we're at, right? Now turn off all redundant layers, because there's a lot of layers. All those layers added in AutoCAD, they are showing here, right? So now we turn the ones that we don't need. Okay, we need that one. Okay, this one we don't need it, right? So when you turn it off, you check whether it's necessary. Okay, this one we don't need it. Okay, we don't need this one. Put this for furniture. We don't need it. We need this to be as light as possible, because yes, we don't need that. Okay, doors. Okay, you see, these are another issue. So yeah, at this point there's this view. Okay, change it to direct 3D. This also like preserves those changes, how it appears, right? So we need our doors, because we need the building to look as close to an actual building as possible. Okay, this one can stay. Okay, this one will stay. I mean, okay, this one should stay. Okay, this one's can go. Okay, this one will stay. Okay, this one will stay. I mean, not going to be much of a challenge, right? So now this is now lighter, and it tends to improve performance while designing, right? So we do that, and then adjust the view. We just did that, right? We went to the ranges and changed it to 3D. It helps to preserve just the details we need, right? So now we lay out the actual pipes, right, and then adjust the sizes accordingly. Okay, and make sure they are on this 0 elevation, right? So the sprinkler pipes are going to be elevated from the ceiling, but before we do that, we need to ensure that they are laid out on the floor for lifting them up. So this is our pipe. Now this is going to, you just click and draw it, and that's another important of, then hold your shift to ensure straight lines, right? This is another importance of drawing it before bringing it here, so that you can draw the pipe. And then also every junction you do a separate pipe for it, right? So because that junction is where I'm going to add fittings, right? So hold shift, so somewhere here. Okay, another thing is you have to be checking the pipe, see that the elevation is correct. If any reason elevation is not correct, you need to make adjustments, right? So this means that they are lined flat on the ground, right? And this is our pipe size. So how do we change that? Double click and then edit your size of pipe here to 1.5. So press enter. It has reduced. So the default is usually 2, but you can change that. No, that's not. We need 1.5. And then you can also make other changes to your pipes if you need to, right? The material and all that, right? But that's not what you are here for. Then this now is going to be 1 inch diameter. Okay, press enter. You see how it's taking shape. So now we continue. These are two types of pipe. This is just one pipe at a time, and this is a continuous pipe. So which one do you think we need? Let's go with this. So we take from this where this is, and then hold your shift and drop it here. That's around where the sprinkler is going to be, right? So double click. I mean, you can find, I'm sure there's a shorter way to adjust these pipe sizes, but I can't really remember it right now, right? So let's move on. So now let's use this continuous pipe and see what it does. So now from here, okay, from here, so this one now is 1 inch up to, oh, okay, I mistakenly left out something here. I didn't import the right let me see if I can, okay, I can adjust this a little. Okay, I want it to be here. Okay, okay, what are we doing now? Okay, what do we need? Okay, add another pipe. So I mistakenly imported the wrong pipe, but we'll figure it out since we're already here, right? So we had a pipe somewhere around the center, so that's where we're going to place this. So we drew another pipe finally to this point. Make sure that it aligns as well as possible, right? Okay, so this one, you hold your shift somewhere in the middle. This is fine. This is fine. Now let's adjust our pipe size accordingly. Right, so this is enter because you just want sprinkler supplying, and you can even see the sizes that we put in the file that we sent in. You can see it here. And then this one should be is supplying 2, so it will be 1 also. Double click and then it opens up this dialog box. Then you make your changes. Now this one is going to be 1/4. Oh yes, you see another thing. This place now shouldn't have been one straight pipe. I'm going to make a also make a break here, right? That break now is going to enable me to, when I need to add a fitting, right? So I can work. It works perfectly. Like, oh no. Okay. Hold your shift to make sure it doesn't move around. No. Okay. 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 So now this is 1 inch, right? So we come here and put this. We add another pipe. There's just a way. I can't remember. There's a way I could change this thing, right? But let's just leave it, right? So this comes here. It's supposed to be at the center, but this is just a draft. So when we add the actual things, we'll see, right? And then we add another pipe from here to meet it here. Right, so now let's edit these sizes. Enter. Okay. So now we are good to go. Okay, let me ensure, you have to ensure that the pipes are aligned as much as possible, because we'll need to add fittings later, and if they are not aligned, it's going to be a problem because it has to snap accordingly. So let's just ensure that every pipe is aligned. You see, this one is not exactly aligned, so stretch it. Okay, this one is not really a problem. Okay, there's a pipe, there will be a sprinkler there. Okay, so we are good to go. So each of them is an individual pipe. This one, it looks like it's not aligned, but let's hope it is, because we need to add fittings soon. So next on our list is, okay, select and elevate pipes specified height. If there are more than one floor, okay, or ceiling height, you select one them after the other. So now you've seen cases where we've designed for multiple floors, right? Where you just put them beside each other, right? So for example, now in this is our summit view walk we did one time, right? Oh shit, that's not what I wanted. Okay, see that. Okay, let's use this. Okay, you see that in this case now you put them alongside each other, beside each other rather, for different floors. So that's also the way you lay it out in this place, and then maybe one here. Then you design the pipes. I mean, all of them will be laid on the ground on that 0 elevation. Then you can now elevate it. So now let's elevate this one to the right height. Okay, elevate the pipes. So now to do this, turn off other layers if you have to, so nothing interferes. Okay, to do this, I want to select everything. So I want to turn off everything else that I don't need, because they're going to affect me. Okay, this is about major pipes. Okay, you can turn this one off. Okay, no, we need that. I made a mistake. We need this. Okay, this is those lines that are there, and then the sprinkler circles too. Okay, can turn off a lot of these things. Okay, so I don't want them to interfere. Normally I can easily select them one after the other, but I want to just select them all at once. Okay, so you are left with just that. Okay, now you are left with just this. There's nothing to interfere with it. So now select everything at once. It's now in blue. Right click and elevate pipes, and then I'll select the height I want to elevate it to, which is 9 feet, right? Because that's our ceiling level, 9 feet. Okay, okay, okay. It's now at 9 feet. See, you see that this indicates at 9 feet. Another way to look at it is to change the view, right? Okay, we can't see it yet, just yet. So let me show you what it looks like. Now you see that this one is on the ground floor, right? On the ground level. Okay, we don't need this. We need walls. We don't need furniture. We don't need. Okay, we need doors. So now let's turn on some of our. Okay, we don't need this. No, we don't need this. Let's turn some of our these things back on. So you can see now that they are at a distance below our 9 feet. Okay. Okay. What else do we need to turn on? No. Okay, no, don't need this. Don't need this. What else do we need? Let's go back. Let's change view again and see what it looks like. So yeah. See that when you look at it on a plan view, everything seems to be on the same level. Where's that door? Okay, this is the door. Okay. Right, what else do we need to turn back on? Okay. Right, so we want to turn back everything on. Let's see. Okay, we are good now. So now these are all our spaces. I mean, so far so good. Okay, we don't need these sprinklers. We don't need it. Okay, we don't need that. Right. Because we're going to, those are just lookalikes, figureheads for our actual sprinklers, right? So what are we doing next? So we've done this. So you go to 2D front or side view. Okay, if you have to, this now is, or I usually use this when the line should be for alignment purposes. I usually use this when I have um multiple floors and I need to align them. So what I do is that I'll go to, for example, this now is, these are the different views. This is the ground level, this is the 9 feet, right? So now I'll just go here. Okay, let's start here. So this is where it meets the wall. So likely the pipe that comes up here is going to be somewhere here, right? It will be hidden in the wall rather than running along the surface. It will be in the wall. So I want to use a line. Draw this line at this point. I start by drawing the line and then I change my view. So now the line is, it was drawn on this point. Now I'll hold my shift to maintain that it's vertical or it's straight and bring it up here. Now, if for any reason I had, now look at it from this view. This is my line. This is my line. If for any reason now I had to put multiple floors on top each other, I'll simply just draw this line on each of them, each of the different floor plans, right? And then I will just align them together above each other. So now you now have this sprinkler level. You have another one that maybe about 17 feet above ground. You have another one that maybe like 32 feet above, right? So what are we doing next, right? Plan through a straight vertical line if you have to. Okay, so that's what we just did, but we may not need it, but let it just be there. Now we place sprinklers accordingly. So in this case, there are different types of sprinklers, but we're going to use pendant, which is one of the commonly used sprinklers, right? So we place pendant sprinklers. So let's do that. Okay, at this level, right? So now this is where we select our sprinklers. These are different types of sprinklers available. We have upright, we have pendant, we have sidewalk, but I want to use pendant, right? So I go back and place them where I need them to be. Okay, I want to place them on this. Okay, no. I mean, I want to place it because if I place it here, it might mistake it and place it on the ground. I don't want it to be on. I want it to be clear. I want to place it here. Then this is not very accurate. Okay, see, it's not exactly starting to where I want it to be. Let me Control Z it a little. Let me place it on this. I'm sure it's going to snap to the point because it's going to identify just to place it here. Yeah. Place it here. And place it here, and place it here, place it here. Okay, so now what do we do next? We apply this auto fitting feature, auto fittings pipe after to ensure proper selection. So now what I'm going to do is I'm going to select. Now this auto fitting is just going to add all the fittings to join the pipes and sprinklers together. So I'll right click on the pipe and select auto fittings. So now you see that has added the fitting here. So that has joined this pipe with this one. And I've also covered this point because it doesn't like open spaces or open pipes. So now I select this and auto fit again. Now it is telling me selection and then okay. You see, this is what happens when the pipes are not properly aligned to each other. Right. So I'm going to select and delete this. I knew that this might be a problem. Right. So I'm just going to ensure that we place them right. So that ensure that they snap to the right spot. So that when you auto fit them, it's okay. Still not quite correct. See, okay. We need it to ensure this. It can be very sensitive, right? I mean, okay. So bring this to meet here, and then bring this to meet. Just try and align it as well as possible, right? And bring this. Okay, let me bring it up here so we can test for sure why it did not work before. Let's do it again. Okay. See how it can be a problem. So let's keep trying till we get it right. So in this case, now it only recognizes these two as being together, so not this one. So delete that because we want them all to be together, right? So that means those two are rightly placed. No. Oh. Okay. You don't want to move. So I just have to place this one so that it. Right. I also want to look at it from other angles, other POVs, right? Okay. This also helps. Okay. Okay. Can get very frustrating if you're not getting it right, right? You just have to ensure that it aligns, right? I think this view is better for it, right? This view is better for it. Okay. Okay, can put this one. Okay, I hope it works now. Let's try again. Might not work. Let's see. Let's just try and see auto fitting. Oh, still not working. Okay, let's try using this one. Still not working. Okay, let's keep trying. Okay. I'll just confirming the size of the pipe. Yeah. And this usually stems when you don't align it from the start. So it's not usually good to be in a hurry, right? Okay. Okay. You may have to start this in afresh because if this doesn't work, we can't go further. Right? You see, in places where it worked, you can see, oh, this is another issue where it did not work. We have to start this work afresh. Let's just go over it again. Okay, so we've gotten it right now. Right, this is kind of fixed fitting we're looking for. So we do that and then select for all. I also see that it also ensures that you're able to add. Now it connects such that the sprinkler is also connected to this, right? So the way to ensure that this works is that right from the start, when you are your laying out your sprinklers on the ground, those lines that you brought in, right, from AutoCAD, ensure that you draw it to snap to the correct junctions, like where this meets this. Let it meet at that point. Like when you're drawing, you will see that it shows up for you to like click, right? It shows green for it to know that it has hit that point, right? And that's how you know that it has met that point, right? So let's do that quickly. So now it just ensures that you get that right? If not, you just get right, and that is the whole point of getting things right early enough. If not, you move on and then it becomes a problem later, right? So after adding the sprinklers, we've now done the auto fittings. Now we select the riser from the left sidebar. So let's do this. I already added the riser here, but let me delete it and add it back so I can see how it's done. So this is the riser already. So let's select it. Oh yeah, select it and then delete it. Okay. Now we don't need this later. Okay. Oh, so there was a cover. Okay. So how do we get that? We come here. Oh, did it here? Okay, auto sprank. We look for a riser. Okay, is a riser. Now the riser, these are the different sizes of riser depending on how much depending on the size of our system. Now this is a very small system, so the pipe is even 1.5. But and in many cases, sprinkler systems are not always designed for all buildings, right? It's usually like maybe specific hazard types or whatever, or maybe just like a specific requirement, right? So we don't always have like meeting some some little pipe sizes, right? So in this case now it's a 1.5, so, but the smallest here is 2.5, so I don't want to use it, right? So there are different ones that go with this 2.5, but let's just go with this first one. So bring it out and drop it. Okay. Now we need to, oh, this is still here. I didn't need this to be here. So now we need to align this to this thing. Okay. I don't need this too now, so I can delete them and bring them back later. Right. So now we need to align. So let's align it from this. So this is what the riser looks like. This, right? Let me move it so you can see it better. Okay, this is what it looks like, right? So this is looking like a pressure relief valve, right? Then this is, so the water comes in here. This is the water it comes in through. The riser just helps to control how the water flows, right? Then it goes up here and then into the sprinkler system. And then this is probably if you need to like connect it to like an external source or something. And now let's move it, right? Now to align this, you need to know how to align it on all the levels. So first of all, let's align it on this level. Now what we need to align is to align this, okay, to meet this. Initially we had just this pipe, right? So I have to just add this, right? Okay, let me just do it now. Delete, right? Delete. So now we come here, draw a pipe. You see it's showing this green now means it's clicking to the end of that pipe, right? Oh, that's another thing with 3D view. I want it to be in this view. So that view. Okay, perfect. Now you draw a line. That green means it's tapping to the end of that pipe, right? So this our pipe is going to be, let's say, 2 inches. But before we do that, let's align this so that it is exactly under here, right? So to get that, we need to go to this view. where's our pipe? Pipe is somewhere. Okay, it's not even here. We even need it. Okay, yes, let's just go with it. This is the end of our pipe, and then this is our riser. So we move our riser until this is directly under. Right, this is the point we need it to be. Confirm from other views. You see from here that it's directly under it. Right, come here and also check from the side view. It's directly under it. Check another view directly under it. Okay, fine. Now another thing we need to check is that this is into the ground, is in the ground, because our water supply is most likely going to come from the ground. So let's check. This is our ground level, right? So we check from here. Okay, it's not exactly reaching the ground because this green line is our ground level, so you can bring it down a little. So this, you press and hold and drag it. No, made a mistake. See, so just hold it somewhere else. Okay, bring it straight down. Okay, straight down. Then just confirm that it is still aligned, right? Let's check whether, okay, yes, it is. It is. So now let's draw that pipe. So now we'll draw a pipe from here down into this point. So now this is our pipe. So we're going to, yes, perfect. That green light, that green does indicate that it has connected, right? But it's not enough that it has connected. I mean, it is enough because it helps in your hydraulic calculation. But I just like to add these fittings just to give it that look, right? Okay. So now he couldn't find a fitting for here, right? Couldn't find a fitting for here. That green just means that it has connected, but yeah, it could find because it doesn't have all the possible fitting sizes, right? Next, we draw a pipe here to show that this is coming from outside, right? I mean, these are just some little basic things. Okay, I want to change the view. Okay, I can use, I think, okay, no, let me use this view. All these things matter. Okay, is it this view? I want to use this other view. Okay, let me use this one. Okay, no. These are just playing around with the views to tell you how it works. So basically, I just want to draw a pipe that extends out like this, right? Now let's look at what it looks like in the 3D view. Perfect, this is exactly what I wanted, right? So now escape, we don't need that command anymore. Then select add our auto fittings. Okay, perfect. So it has joined accordingly, right? And it has also given a cover here because it doesn't like open pipes. Now what next? We've done all that. We added the riser, okay, which we've just done. We've aligned it to the pipes with the heights and everything, the elevations. Now we add water supply. Now it has an option for water supply. Remember we talked about how water is supplied to the system. So this is how we add it, right? So now on this, now we are going to add all the features of that water supply. Okay, so we spoke about static pressure, spoke about residual pressure, and all of that. So now let's select values that are going to meet our system. So for we had a range. Okay, I don't want to go to that. Okay, let's just go there. Right. Okay, we had a range. Okay. A range for each of these. This is what we're looking for. I don't know this. If you can close it. Okay. So for static pressure 50 to 85, reserve pressure 25 to 60. This. So I mean, this is a small building and it has very small demands. I'm just going to take like values on the lower end. So for static, we have, let's take 50, right? 50 psi. 50 psi for, well, let's take 55. 50 is too low, right? I mean, we'll do our calculation and then we'll see whether it works or not. That's the point of the calculation. For residual pressure, use 30 psi, and then for the flow, we got 225 for that one example with this, but let me use 300, right? I mean, I'm just giving a higher estimate, and then, right, then what again? Outside host flow. This is the supplemental flow. We call it 100. So press enter. So now we've given this water supply the necessary values, right? Now this water supply is going to supply into, as far as all the pipes are connected, which those green snapping points were showing all that time, so they're all connected, we were able to ensure that we can perform our hydraulic calculations, right? So select the riser. We've done that. Add water supply. Okay, 85 psi, 55, and here this is for like average values, right? Higher values, but that building is quite small. Now turn the floor layer back on and draw the most remote area. Now remember that design area we spoke about. This is what it meant by that. Although in this app it's called remote area. Okay, carefully check the other side does not snap to the wrong levels. So I need it to be drawn on the floor, right? The floor level. So let's do that. Right. Okay. Let's use this. So now how we do that is we come here. This is where, let's look at this first. Remember I told you that it's about 1.5 per minimum, right? But this building is smaller than 1.5, so we can't really use that, right? So let's delete it. Okay, let's see what it shows. See, 1.5 feet. I mean, this has, but we don't, we are not going to use, we are going to use the maximum size of this building now. The maximum, we're going to assume that the whole space is the, because I mean it's smaller, right? And use the whole point of that 1.5 now is that if this size now is about maybe 2,000 or 3,000, and maybe 1.5 is like maybe this section, this is the most remote part of the sprinklers, right? We'll just count that 1.5 in this point, right? And then take it as our design area. But for this, we're going to take the entire space, right? So we're going to test. This means we can draw it ourselves, and this means that we're going to draw it at 0 feet, right? So come here, draw it, right? Now it may not be very okay. This is, we are not, that is, don't forget that that is the free refrigeration, Abi, this place. So we are not the cold room, we are not drawing for that. Okay, so this is it, this is it, this is it. They've shown you this floor area is quite small, and then they've shown you that for ordinary group, right, this is also the hazard they've assigned to it. It's not up to you to make any changes you want to make, right? Okay, now this is where we can, when you double click on that area we've drawn, this is where we can select the different hazard types. It is ordinary group 1, so we leave it at that, right? Okay, and then we also see this is the correct value, right? I mean, already by the time I select ordinary group 1, it's going to change the values accordingly, right? Okay, so that is that. Now these values, right, just gives us an idea of the pressure levels or the stress levels at each point, and you see that it is usually higher, or it's usually indicated at the points where fittings are. This just goes further to tell us that the fittings can either make or mar your system, in the sense that in terms of maintaining the pressure and flow. Now this is another problem with selecting the whole area. This is why I should not select the whole area, right? Because basically, right? So moving on, let's see if we can spot any trend. So you see that this 104 is around the sprinklers itself, and then this one I just counted as 1, 2, 3, 4, 5 is around the junctions, right? So we can even select and edit them. Okay, select and edit them. Now what I like to do is that Okay, no, I can't. I think I can use three. I can use three, even though it has been used before. What I like to do is that I select just a small section, which is like the design area, and then it gives me an idea of the pressure levels around, or the pressure points, call it pressure points around that point, and then I just rename it and number it accordingly from the beginning, right? So it's 1 2, let's even do it 1 2 3. This is just to make it presentable, right? Although I'm sure those figures have meanings, right? But as it is, can't really explain what they mean, if I'll be entirely honest with you, right? So just do that for all of them, right? So next, what do we have next on our list? Okay, add water supply, we've done that. Turn the floor layer back on. Oh, we turned it back on too early that time. Now select the correct hazard level, which we've done, and generate a remote area table. We have started going into the calculations now, right? So now to get that remote table, you right click on this and get remote area table, drop it here, right? Now it's giving us values. Now we've seen the occupancy classification, the density, the total host streams, which we added as 100. This is that supplemental water supply. Then dry capacity. We don't have any dry pipes in our building. Then total heads. This is number of sprinkler heads, and you see it's 5 of them, right? What again? Key factor 5.6. Now let's see how we can adjust these key factors, right? You right click on this now, or you just simply double click on it. It gives you the features, right? So you see that you can adjust the key factors of the sprinklers and then other details. Now this is initially, it gives you like a minimum of 5.6 or a standard of 5.6. Now if for any reason your remote table is not giving you a positive value, because this positive value here just indicates that our system is good to go. Now there are some cases where this value is negative. That means that we need to make changes within our system, like in terms of pressure or flow or K factor, right? And by the time we edit all those things, we're going to get it to be positive. That means now the system passes, right? Okay. So this is the riser we selected. I mean, all of these are just like automatically generated by the software, and it gives us an idea, right? So this is the K factor. So if we needed to change it, we can change it for. Remember that we can have different zones in a building. So this K factor is a perfect way to select different types of sprinklers or different ratings of sprinklers for different species, right? So I mean, you can select them one after the other. I mean, if you want to, you can find the shortcut to select them all at once and change their values. But if you select one after the other, you can make changes. Press enter. Now if I right click here, let's look at this table 6.956, 34.561. If I right click here and do that, the table is going to be updated based on what I did there. You see that it has changed, it has dropped. So instead of helping me, that change that I made actually did not help me, right? So I mean, all of these things are dependent on the type of the system, right? So next is to get the reports, right? To print the reports. So now to do that is not difficult, being that we've already got into this, but we're almost done, right? So let's change it back. Let's change it back to 5.6. That one is good to understand what changes you make, what effect they can have. Okay, so let me go back to, where is that? Okay, table. Now it has updated again, so back to the way it was. It's now how to get our reports. So we simply select here, and no, it's not here, sorry. So you go to hydraulics. Okay, we need to have selected this. Select this, go to hydraulics, and then is it analysis reports? No analysis reports. Okay, hydraulic reports. So to get this, now the ones I usually just require, there's a lot of different, I mean, depending on what you're required of, but there are some basic ones I just use, which are listed out here. So hydraulic overview, riser tag, these 5 of them in that order, right? And I arrange them with Bluebeam, right? So we do this. I mean, we spent so much time already, so let's just quickly. I'll print just once. I see it. Hydraulic overview, right? Print just that one, which is already selected. Remove all this one. I just like to print them one after the other, so I can name them properly. So I can preview, but we don't have time. So let's print hydraulic overview. So it's preparing the report, right? Oh, I wonder why. Okay, I think it has downloaded. Okay, it does that sometimes. Let's check whether it's really downloaded. So this is what the report looks like. Right, it gives us. Oh, this is bad. This is bad. This shouldn't be. Well, let's see. Okay. Let's go and see if we can change stuff. Let's try printing something else. Call it riser tag, for example. Let's print riser tag. Okay, riser tag. Okay, print report. Okay, now it shows us where we can select. This is our original folder. So just write the name I want it. Riser tag. Right. Save. And then it does it for me. Right. So that's access denied. I don't really know why it does that. Okay, this is what it looks like. This is what it looks like. So it opens it up, gives me a summary of some of the information I have on plan. Right. I mean, by the time you print all of the other different reports, you get more information according to what you want. Right. So you do that, and then we bring it back to. Now we can export this as a DWG, right? Separate floors banker. If you have this, if it's multiple floors, and then export as DWG. Let's do that fast. Okay, we don't need this anymore. Okay, we need it. Let it be there. Right. This is our ordinary group. Right. Very good. Okay, this is our remote area. So press escape. Right. Now this is our table. So now export. How do we export now? Okay, this was the import. This is to export and as a AutoCAD file. Yeah. So from AutoSpring, right? That's how I'm just naming it. Right. Check if you need to make any changes. And then okay. So it exports it. Okay, it's done. Now I go to my folder. It wants to hang. But we are done, thankfully. Okay, this is my folder. Right. From AutoSpring. Okay, is this it? From AutoSpring. It's like it didn't work. Oh. And this is that riser tag. That's it brings it out as a PDF, right? Ah, it's like it did not export to AutoSpring. It didn't export, so we'll have to go back and get it. You have to go back and get it. So let's go back to the file that we're using, the AutoSpring file, which is this. Let's export it again. Uh, okay. Now I don't know why it does this, but I can help by doing this. So it changes, removes it. Now let's export once again. What an AutoCAD. Okay, perfect. From AutoSpring or two. Okay. Save. Okay. Oh, That's closed again. That is serious. So when it does that. Right. But basically, right, once I'm able to do that, I'll just open the file and then I copy out what I need. Basically, what I need that, I mean, the layout, I've already done that layout with AutoCAD already, right? But I just need AutoSpring to give it that realistic look of the red pipes and the sprinklers, because it actually shows very realistic rather than just these circles I used here. And then we'll have the table by the side. I don't know why it didn't work today, but maybe by the next class I'll be able to figure it out and it should work by then. So thank you for showing up today, and I hope that this class was beneficial to you. So till we see next time.